Ladies and gentlemen, up next, I'd like to introduce Jason Cook, Systems Engineer at VeriSign. Give him a big round of applause.
Hey everybody, how you doing this morning? Good? Yeah, it's early, I know. I was telling Mike, I don't know if it's a good thing or bad thing to be first one on the last day. I guess we'll find out, right? It's actually nice to be presenting to you guys. I guess you're kind of my people, my Nagios people. Even when I present this in the company, everybody's like, monitoring, this is great, fantastic. But I'm among my people now, so that's awesome. So I wanted to talk to you today about Nagios and Mod Gearman. We're kind of a large-scale environment, VeriSign. If you didn't know who we are, we used to be an SSL company. We're not anymore. We're a DNS company now. We manage .com and .net registrations, and we also have 2 of the DNS root servers. So we manage that infrastructure. So brief history of Nagios at VeriSign. We started off with a passive environment, typical white paper NSCA. It's a 3-tier setup. Here's a diagram. 3-tier setup, remote systems that run a Nagios daemon, run their services, send the results back by way of an intermediary Nagios server up to our central Nagios servers. It was in place for several years and actually still is. We're still migrating. It's pretty stable, though it does need some babysitting and hand-holding. It's very heterogeneous, so we have a ton of OS versions, many Nagios versions, all the way from 1 up to 3. All of our notifications actually aren't handled necessarily by Nagios. They're just SNMP traps out to an external event management system. And all of our performance and trending is actually sent off somewhere else too. So we don't manage that in Nagios with PNP or anything. So here's sort of a simplified architecture. So one thing to note is, I don't know if people do this at other distributed environments, but for some measure of redundancy, let's just say we have 2 distributed Nagios servers per environment. Each system connected sends to both. So that creates something of a split monitoring network, right? Like where we'll end up with the same monitoring result in 2 places, and then it ends up at redundant central Nagios servers. So we actually have to do deduplication of notifications as well, which is a gigantic hassle. So here's some challenges, and actually I'll go back to this slide real quick. One challenge is when we're managing this layer, or even this layer, but in particular this one, if we add another server, we have to reconfigure all of these systems to use it. So if we replace one with a new name or IP or whatever, these have to be configured. And these systems are managed by many operations teams. So coordinating that is a challenge, to say the least. If we add another one at this level, we have to reconfigure all of these, which is less challenging, but still a pain, because everything above it architecturally has to know about what's being changed. So our challenges, as I mentioned, the scaling. And then, so for load balancing, we have to remove those freshness checks. It's such a hassle otherwise if we don't. I can't even say how much of a challenge that is, freshness in general. More freshness checking means more Nagios forking, and forking means sadness. At least in Nagios 3, it's bad in a large environment when Nagios has a lot of work to do. It can't fork fast enough. It can't, and the forks are quite large, so they use lots of memory. They use lots of CPU. So you have to offload as much as possible. And in a passive architecture with freshness checking, you inadvertently end up with an active environment anyway, because you have to check to see if the results have actually been received. So whether you intend to or not, you're going to have an active architecture. We actually did something to mitigate this, though. In combination with live status, I wrote a plugin so that, for going back to this slide, at this layer, I'd run one active service for each of this level systems to see how many stale services there are, so that, and then disable internal Nagios freshness checking across the board, so that we have one active service that will alert to say, hey, we haven't received anything. And then same on this layer. I'd run that check against these. So that, in a lot of ways, mitigates the freshness issue, but it's still a pain because we have to do that. So another one is lack of centralized scheduling. So think of the Nagios UI. You have a user that wants to run a plugin immediately. They can't do that in a passive architecture, at least not simply because we don't run UIs on every system. We're only running the daemon. We only run the UIs on the central Nagios layer. So I also have to support Nagios builds for all of our platforms, which is a pretty big build. That's a pain. Since we're using NSCA, we also need libmcrypt, which is not standard with anything. So that's yet another package to maintain. And also on some platforms like Solaris and AIX, it's not easy to build. And then on top of all of that, we need the custom code here to handle the intelligence of when networks go down, and then also to queue the NSCA results and send them in bulk. There's a project out there called OCP Daemon that does something similar to what we do, but ours is kind of custom to our environment. In particular, we do detection to see if the remote side is down. If not, go to another place. We just have more logic in there. So with all those challenges, we've got to find something else, right? So active monitoring. So Gearman. It's an open source job server, allowing Nagios, or really anything, to create a job and to have a worker satisfy that job. It integrates with the mod Gearman neb module, and we're using NRPE on the remote sides. Merlin is also in place. Merlin is written by OP5. It allows you to do load balancing on the Nagios layer. Here's another sort of simplified architecture diagram of it. So we have our central Nagios servers, again, balanced by Merlin. So scheduling is shared, talking to multiple Gearman servers. And those Gearman servers are talked to by all the workers. The workers reach out to the remote systems by NRPE, check NRPE. So a new thing for us is we're running everything in VMs. Before we had lots and lots and lots of hardware. Lots of hardware. So everything's in VMs now, ESX. We're running Nagios 3.4.1, Merlin 1.1.5, which at the time, as of a few months ago, that was the most recent version that supported Nagios 3. I understand there's a newer version now, so we'll probably be upgrading to that. And then mod Gearman 1.2.6, live status, that's a big one. I mentioned it before. Probably the greatest neb module of all time. It is so useful. If you're not using it, you should, because there's so much information you can get out of it in real time, too. The Merlin setup is a simple peer-to-peer, or at least I thought it was simple. Talking to Andreas, I guess most people don't use it like this, but we spread our Nagios layer very wide to share the scheduling load. I guess most people don't do that. Mod Gearman neb module configured to talk to multiple Gearman servers. So back here, the idea is, in Mod Gearman, you can set up a primary and then comma-separated backup servers. So, for example, we'll have Nagios 1 talk to Gearman 1 primarily with 2 as a standby, and then 2 will talk to 2 with 1 as a standby. So if we lose 1, we still have live traffic on 2, and 1 will eventually fail over to 2 anyway. So it helps us balance our load, and we get better redundancy out of it. And so on the workers, we have one process for each Gearman instance. Even though we could do the backup thing too, we just start up multiple processes, one for each Gearman server. And so you could scale that out as wide as you wanted to, which makes a pretty redundant architecture. So here are the configurations, just sort of a base, simple configuration. 4 vCPUs, they're running on current off-the-shelf gear. 2 gigs of RAM. RAM isn't very important in this architecture, actually. And then Linux 2632. Performance considerations, it's very CPU bound. This is all about CPU, nothing else. At least in this architecture, when we've disabled logging and all of that, we don't use disk, we don't use RAM, it's just CPU. For this example, I'm going to show you it's just 6 instances, 2 servers, 2 Nagios servers, 2 Gearman servers, 2 workers. So this is what we're shooting for, 100,000 services at 5 minutes, so 20,000 a minute. Some of the Nagios configuration parameters, sleep time is 1/100th of a second. Host intercheck delay method, everyone know what that is? The delay methods. So, without getting into the nitty-gritty of the scheduler, it's how the service checks are spread out. So, with N, there's no spread between the scheduling of host checks. They're all just scheduled at the same time, spammed out. The reason why we want to do that is host checks are very important to us. If a host is down, we don't want to check their active services. So if we mark a system down, we're going to mark it unavailable for service checks as well. So the host checks are extremely important to us. We want them done as soon as possible. For service checks, we're scheduling them at 1/100th of a second of a delay between them. Normally, these are both set to smart, which will take an average of your intervals between your service checks and try to intelligently schedule them out. The problem is when you have a variance of intervals in your services, like say Mike was using an example of some run at 15 seconds, some run at 10 minutes. That average gets thrown off. And so it can't necessarily schedule everything correctly. So we always set a standard spread of 1/100th of a second. The max concurrent checks, we always want everything to run as many as possible as you need, as many as it needs to. 5 Gearman collector threads, what that means is we're going back to our Gearman server with 5 threads in the Nagios, each Nagios server, collecting the check results that come back. The Gearman server itself has 10 I/O threads, which means 10 threads to accept inbound requests, both from Nagios servers and workers. That could be higher, but for what we're doing here, that was fine. Mod Gearman workers, so they're sort of set up like Apache, where you would set like a max clients, right? Where you would have that many number of processes. It's sort of the same thing here, where we set 1,000 max processes and 50 per second spawn rate. Here's a performance graph. Load averages. It might be a little hard to see, but loads aren't very high, actually. The Nagios servers are actually down here. practically nothing. Average is 0.09. These are 15-minute loads too, so trying to give a better sense of the overall load. Because obviously there's going to be spikes inside of any given minute when Nagios is kicking off checks, but just to show the overall load, Gearman servers also averages 0.01 and 00. They're practically doing nothing. And then the workers are the ones you're seeing kind of the spikes on. Those are obviously getting hit the hardest, but they're also the easiest piece to scale because you just add another instance, point it at the Gearman servers, and away you go. So some observations. We can easily handle 20,000 active services per minute. It seems like a lot. This isn't actually our production environment. Our production environment is actually much larger, but it's very much the same architecture, just bigger. Additional capacity can be had very easily. You add more Merlin workers or Merlin peers, you add more workers. It scales up very well. It's linear as far as I can tell. Renicing is definitely important. You gotta make sure you renice your processes so that they're given the priority that they need. But the environment can be a bit fragile. It's a lot of moving parts. The Nagios component is fairly straightforward. It's Nagios just like you know it. But the Gearman piece is probably new to people. So managing that adds another layer of complexity, I guess, to it. And then also Merlin, it's its own daemon. And they communicate with each other. So you create a mesh network of Merlin instances as well. But the benefits, much less hardware. We're talking on the order of 20 times less hardware to manage our entire monitoring. That's a huge win. The centralized view and control over all of our monitoring, that is very valuable too. We can, from a centralized location, see the health of everything everywhere, as opposed to kind of a best guess in a passive architecture. If something goes down, why did it go down? I don't know. Can't tell. All we know is that something didn't come through. That's unfortunate. With active monitoring, that's not a question anymore. So we also have the opportunity to leverage the Gearman architecture for other services. So for SNMP polling, for example, just throwing that one out there, not saying that we do that, but one could write an SNMP poller off of Gearman, right? So you insert a job, say, I need this host polled. You write a worker to collect that job and say, okay, well, here's an SNMP walk, blah, there's the data back, and process it, give it to your graphing engine, your back end. It's really simple. Gearman.org actually has a lot of API examples in pretty much every language to interface with Gearman, so that's really cool. Flexibility in the scheduling logic. So we have a lot of data in our backend. I don't know about you guys, but we keep all, we have tons of databases about the health and status of our architecture systems, things like that, that aren't necessarily available throughout the entire network, like on our edge, for example. So we can leverage that data to actually to modify our scheduling, to enable or disable checks, to make timings more aggressive, to scale them back, whatever needs to be done. So that's very cool. Event handlers become very useful. So something happens, you're in a position to actually do something rather than just being at the whim of a result. So an event handler gets triggered for something, right? We can disable event handlers on, we can enable that in our Gearman architecture so that our Gearman workers can also act on event handlers. That's cool. So let's say a service dies, it has the opportunity to go out and do something to try to fix it. Whatever that something is, you write that in an event handler. That's extremely useful. We tested a bunch of different methodologies before getting to Nagios and Gearman. Multi-site DNX and NRDP, excuse me. Multi-site, so it's good, and it definitely does something along the lines of what we would want to do, but it would require Nagios instances. And so scaling it would be much heavier and much more configuration heavy. So we didn't really like that idea so much. DNX, it's not really supported. It looked like there was some life in it last year at this conference, but turns out not. NRDP, if I had to do our passive architecture over again, there's no doubt I would use NRDP. That is definitely the way to go rather than NSCA. NSCA is not good anymore. Probably never was, but NRDP is definitely the way to go if you need to do passive. The current design is definitely still a work in progress. I don't know where we'll be next year. Right now we're on Gearman. Nagios 4 could change all of that. This conference is pretty much the first I had heard about it, so we'll see where it goes. And then moving anything possible off of Nagios is critical to scaling this up. So the credits. VeriSign system administrators for helping me test all of this. Gearman console labs for Thruk. Thruk is a web UI. Does everyone know what it is? No? Okay. It plugs into MK Live Status. So you run Live Status and you're querying live data out of the daemon. The standard Nagios CGIs actually just read from log files. In a larger environment, those log files get really big. I think when we were generating our status log file, it was probably 150 megs, 200 megs. So hitting that on your CGIs is quite a challenge. So using Thruk, where it talks directly to live status, it's a similar UI to what you'd expect from the Nagios CGIs, but the source is live status rather than the log files. So it runs very, very fast. It also has some fancy features about it, but it's kind of ugly. OP5 for Merlin, huge thing for us because we can now scale our Nagios component very wide. Another thing I actually didn't mention is because we're scaling it so wide, our Nagios layer, we can actually put a load balancer in front of it now and actually have it be very functional. So we have Nginx to front our Nagios systems. And so when users hit the Nagios UI, they're actually hitting Nginx, which is spreading out to however many Merlin peers we have. That's awesome. Before we didn't have that. As I said before, with our passive architecture, we actually ended up with several kind of standalone Nagios instances that hopefully had the same check data because of this, right? So before you're hitting the UI on one of these two, hopefully they're the same because they're being sourced from the same systems. But you know, if there was a communication problem, maybe they weren't the same, and that was an issue. We didn't know which was true, which wasn't. Essentially, they operated as standalone Nagios verticals, right? So you had one there. Imagine that much wider, and that was a problem for sure. But now, with this, we don't have that. We can scale it out as wide as we want and then put Nginx in front of it, and we have just a completely redundant Nagios architecture. It's really cool. And so, of course, Nagios for Nagios Core and NRPE and everybody who develops Nagios Core. Everything is Nagios Core. We haven't actually tried the XI product. Not that I have any beef with it. We've always been with Core, so there hasn't been a compelling reason to change. NRPE is obviously fundamental to this, so we definitely need that. We're so thankful to have it. It's a great lightweight agent to run on our systems. So actually, that ended up going much faster than I expected. Anybody have any questions? I know it's a lot of information. I didn't know how deep to really get into it, like configs and things. That's boring, I know. But does anybody have any questions about it? Mike, what was your question from earlier? You'd asked me about do I have passive? Any passive checks with Gearman, right?
Right. I don't know. Okay. So my question was really related to passive in terms of mod Gearman because of its flexibility. That's one of the things that I've looked at for a long time is it can do so many different things for so many different people. So my question was if you guys were using passive yet, mod Gearman in the passive respect.
Right. So at this point, we don't have any passive results. We could, though. We could have a monitored system kick off a job and actually passively send a result down to the Gearman servers, which would then be picked up by one of these guys. It's certainly an option. Nobody's asked for it yet, though. So right now we're all active, which I like, but obviously for everything it's different. If there was a need for a passive, we could support it.
I guess another question would be is if someone wanted to take your model and instead of spreading it wider, just make it vertical, then they could eliminate Merlin. Is that correct?
They absolutely could.
That's what you're using Merlin for, is to scale, to spread out the Nagios.
Well, and so one aspect, because we're using VMs, the overall individual instance performance goes down. We can't run as much per VM instance as we could from like a physical box, right? So absolutely, you could have a beefy physical box, and then where you put the actual Gearman server could be the same box, could be a different one, but you could absolutely build it quite vertically, and actually all of those components could run on the same box. You could run Gearman and a Gearman worker, the Gearman D and a Gearman worker and Nagios all on the same box. And actually that's beneficial too, because you're taking that load off the Nagios daemon itself. So you're still getting a lot of performance benefit. I haven't quantified it. I've never run that particular configuration, but just by not having the Nagios daemon actually run the plugins, you're gaining yourself a ton. So even if you run a mix of passive and active, or you have a little active architecture, you'd see a ton of benefit just by dropping Gearman D, mod Gearman, and a Gearman worker on your same box. Nagios will run so much better, and you'll use many less resources in it.
I know I've seen exactly what you're talking about with some 5,000-10,000 checks and running it all in one box. And I can't quantify it exactly, but sometimes you're looking at 20%.
Yeah.
It's a very significant amount.
Yeah, absolutely. As I mentioned, taking as much load off of the Nagios daemon as possible saves you a ton of resources, just because Nagios can be, at least in 3 and before, can be kind of heavy whenever it forks itself to do something. So any job that it's going to run, it needs to fork, whether that's a plugin, a notification, anything, it forks and then does it. So it creates an exact copy of itself. So however big your process is, right? Ours are probably 500-600 megs, something like that. So every time it forks, it's another 500-600 meg copy. Just that gets very expensive. Even in smaller environments, say it's 10, 20 megs, right? If you're running a bunch of active checks, you're getting all of those processes just spun off of Nagios that you don't need to have. With Gearman, the work would be done by the worker, which is much lighter weight.
Anyone else?
Mike Guthrie.
You'd mentioned you weren't using PNP for performance data processing, and I know that for people with larger installations, that can be, a big user of, CPU and disk.
Yeah.
Maybe if you can just kind of give a brief outline of what you guys are doing with performance
Yeah,
data.
sure. So it's an in-house design, but essentially we're using a big RD cache D farm and a UI that we built ourselves, but that's not really important. What we are doing, though, is from a Nagios perspective, we have an NSCA listener that I wrote that actually just receives passive results from Nagios into our graphing architecture. So it reads the NSCA results and says, oh, I know about this plugin, I know how to graph it, and then writes out to tells RD cache D, here's the RD, update it with this value. So in many ways, it's very much similar to PNP, although it's built to be away from the Nagios architecture. But it's still receiving that raw Nagios data feed and then parsing it out from there.
So you're essentially just using like that as your performance data processing command, or passing it off to that?
Yeah, so the specifics of it are we're using the performance data pipes, and then we have a reader that reads that out. Actually, I took it from our NSCA architecture. So on every one of these systems, we had a queuer. I was talking about it reaches out, makes sure that the remote listener is working. But so it reads the performance data queue, does a little bit of processing on it, and then spits it out to our graphing architecture. So it's the same logic that we had from our distributed architecture that I actually just put it into our new one. Actually, it's in the old one too, but to feed performance data over to our graphing architecture.
Can you talk a little bit about your experience with bootstrapping Merlin? Did you guys have the commercial product? Did you get to use that tool, or did you just manually?
No, it's just DIY. It's kind of the philosophy of VeriSign is do it ourselves whenever we can, for the good and the bad. No, this is just checking out the source and building it. And like I said, a peer-to-peer setup in Merlin is actually very simple. It's probably the simplest setup that you could have. So you populate the database on the back end. There's a MySQL database. There's a script, import.php or something, to populate the database initially, and then you point your Merlin daemons at the database and at each other. So wherever you're going to have a Merlin peer, you configure all the peers to know about everybody. So like I said, it kind of creates a mesh network of Merlin instances all talking to each other. So they all know about each other. When one dies, the others will take over the scheduling load left by the dead instance. So it's actually very easy. I didn't really have any troubles, I don't think. The initial setup probably only took me a couple hours, I think, to get it working. It was very simple. We did run into some bugs in Merlin in the older versions. One in particular, which was a little hard to find, was it started core dumping after 1,024 config files. But it didn't give any indication of that's why it was doing it. It was working 1 second, add another config, and you start it up, and core dump. No good. So we revved the Merlin version, and it was better. So since then, we haven't had any issues. They can get out of sync sometimes when that. So again, that's just monitoring, right, to make sure that all of the Merlin daemons are behaving. If they do get out of sync, you just restart the daemon, and it's fine.
Any other questions for Jason?
Do you guys store any historical data for status or anything like that?
Not for, well, I shouldn't say that. We have Splunk to mine logs for whatever needs to be captured is captured through Splunk. Nagios in particular doesn't have any requirement, though we do Splunk those logs. It's for just operational reasons. When we do have, some sort of, regulatory requirement, whatever, we do use Splunk to capture our data. And Splunk actually plugs in really well to this architecture as well. Not specific to this necessarily, but the Splunk Nagios modules work very well. And then we put little links on the UI to Splunk this host or to graph this host, and that links off to our graphing architecture as well.
All right, I think that'll wrap it up if anybody else has any questions. Well, we can go ahead and give Jason a big round of applause.